Hello everyone, welcome to my channel. Let's understand. I am Amal and a software engineer. Let's understand our today's topic, computer and programming languages. In today's video, we are going to explore relation between computer and programming languages. All we hear about computer and software, but rarely we think how it works and how much it contributed in our day-to-day life for making our life easy and smooth. So, computer is nothing but a set of hardware, and we call that set of hardware as a machine. For working this set of hardware, we need something that is called software. A software is nothing but a set of instructions, and making that software is called programming. So, on computer, the software rules on hardware by telling them how it works. The process of creating software is called programming. Eventually or virtually anyone can learn how to program computers. It's required only some grit. Why learn programming? So let's understand why we need to learn the programming. We all know that computers have become commonplace in our modern life. Applying ideas in different fields requires programming. Programming can be loads of fun. It is an intellectual, engaging activity that allows you to express yourself through remarkable, beautiful constructs and structures. Programming develops valuable problem-solving skills, especially once the pertain to analysis, design, and implementation. Programmers are in great demand if you know today's current market. Before going to further in computer programming, let's understand some basic hardware. To be successful programmer, you need to know some details of how computer works. For instance, understanding the basic of hardware will help you analyze the performance or efficiency of any of your program. You are a programmer and you are going to write a program. So how your program behave on the particular machine. For a better programmer, you need to understand the efficiency of your program. Will the data of your program fit in memory? When you going to write a program, make sure that the data consumed and produced by your program is feasible in memory. If not, how would that impact the performance of your program? Suppose that if your program is going to consume some TB or GB, some TB or petabyte of data, but your memory does not have that much memory. So how your program is going to be performed? Is your program CPU bound or input output bound? There is two type of program. One is the computable and one is the input output loadable. Is CPU bound? How powerful is CPU? Suppose that if your program is too much engaged in computation, so how much your CPU is able to handle? If input output bound, how big is your disk or network bandwidth? Let's view some functional overview of the computer. We know that in computer the main idea come from the computation, and computation will be done or is done on the data. So whole computer industry based on the data, and it is going to be processed. So for processing the data, we need mainly three things in computer. One is the input, one is the computational, where the data is going to process, and after that the output. So whole computer industry is based on only these three modules: input, process, and output. Let's understand one by one. Hard disk. Hard disk nothing but let's take example from our day life. Just like a copy. When you go to your classroom and teacher giving the lecture, so you are noting down on your hard disk. Suppose so that whenever you need to again refresh that information, you open the copy and see the information. So hard disk nothing like the copy of your information to store permanently. The secondary memory is now come to the point. The secondary memory is where you save program and data reside. Just I explained like I was talking. It is non-volatile storage. It is non-volatile means when you off the computer and again on the data is present there. That is when the power is turned off, your program and data will not be lost. Just I give the example. Now come to the our main memory. That is random access memory. Main memory is nothing but like your brain. Suppose that when you study in your classroom, everything in your mind. But after 2 days, 3 days, your mind is going to refresh. Suppose that you forget that thing. So what you need to do, you open your copy and see the information. Now your brain have that information. Main memory is something like this. So secondary memory have every data and main memory have the current data. The data which is currently in process. The main memory is much faster but more expensive than the secondary one. However, it is volatile. Volatile means the when you off the computer and you on, the data is refreshed. So main memory is going to be refreshed. Your program and data are copied from secondary memory to main memory for efficiency reason. Now come to the CPU. The central processing unit CPU is the brain of the computer. It can at least perform. So suppose that main memory have the data. So how data is going to be processed? Now your main, I give the example from copy. You see the data in your brain, but how that data is going to be used? Your brain going to be do some computation over that data and produce some results. Something like a teacher asks you, who is the Prime Minister of India? Who is the Prime Minister of India? But you don't remember the name. So you open the copy and see the name, and now your brain have the data, and you process that and give provide the output by telling them the Prime Minister of India is this. So the same way when computer is open and you need to do some work, the data is placed from the secondary memory to main memory and it is processed by the CPU. Just like example, arithmetic operation, adding of two numbers, logical operation, tested number are equally or not. It can directly access information stored in main memory but not the secondary memory. So our CPU is not directly access the data from secondary memory, it's always access data from the main memory. So come to the point. By example, input device is like a keyboard and mouses. CPU and main memory have inside our cabinet, and secondary memory is the secondary storage where data is stored, and monitor is our output device, or printer, or projector. Now human interact with computers via input and output devices. So now how human going to interact with the computers? By typing on the keyboard, by clicking from the mouse and seeing the output from the computers, or taking the printout from the printers. Information from input device are processed by the CPU and made by suffer of the main memory or secondary memory. When information need to be displayed, the CPUs send them to one or more output devices. Now come to the programming languages. Now you got the better idea how computer work, how input devices and output devices work, and what is the work of the CPUs inside the computer. So come to the programming languages. So a program is just a sequence of instructions telling the computer what to do. Now computer, I already told you before that computer is nothing but a set of hardware, and that hardware is simple, we call that machine. And how that machine is work? By the software. So software tells that machine that what you need to do. And for creating a software, we do programming, and that programming concept is called program.
So a program is just a sequence of instructions telling the computer what to do. That means we make some piece of instruction, that is the software, and that software will handle to computer what need to do. Obviously, we need to provide this instruction in a language that computer can understand. Now that software is run on the hardware, how hardware know that what need to do. So just like us, when we need to communicate with a different person, we talk in different languages, just like Hindi, English, France, and our regional language. Any of that human can understand. But computer only understand binary language, 101. So for working on the 101, we develop different type of high level, low level languages, and that's called the programming languages. We refer to this kind of languages as a programming language. Already I know. Example: Python, Java, C, C++ are example of programming languages. Every structure in a programming language has an exact form, that is syntax, and a precise meaning, that is semantics. Just like our English, for talking in English, we need to use grammar. So that is, and some rules, just like full stops, commas, semicolon. So this type of syntax also used in languages, and they have their specific meaning. Now come to the machine languages. Python, Java, C, C++, C Sharp, all are the machine languages. Strictly speaking, computer hardware can only understand a very low level language known as machine language. That is 101. If you want a computer to add two numbers, the instruction that our CPU will carry out might be something like this. Load number from memory location something into the CPU. Now load the number from memory location something into the CPU. Add that two number in the CPU, store that result into memory location 2033. A lot of work. Now in high level language it is easily understandable, just like C equal to A plus B. Either it is Python, C, or C plus plus, Java, anything. Much easier. But we need a way to translate that high level language into the machine language that a computer can execute. To this end, high level language can either be compiled or interpreted. Now here compiler and interpreter come in the picture to convert these high level languages into machine languages. A compiler is a complex software that take a program written in a high level language and translate it into a equivalent language in the machine language of some computers. Now take us understand with the pictures the source code program. Source code is nothing but a program which we written either in C or C++ or Java. Now compiler do their task to convert this source code into the machine code, and machine can understand this program and run this program and take input and produce outputs. So this is the basic structure of the compiler based programming language. Now come to the interpreter. An interpreter is a software that analyzes and executes the source code instruction by instruction. That means line by line on the fly. That means at the runtime as necessary. So now see that if you have the program just like Python is a interpreting language, and source code come to the computer and it's run line by line and take input and provide output. Now Python is an interpreted language. So let's understand what is compiling and what is interpreting. And compiling is a static, that is pre-execution on short translation. Means that before execution, it's a compile and see that it's execute that source code in the machine code. Once program is compiled, it may be run over and over again without further need of compiler or the source code. Interpreter is dynamic, that is happen during the execution. The interpreter and the source code are need every time the program runs. Compiled programs tend to be faster, while interpreter once led themselves to more flexible programming environment. They can be developed and run interactively. Note on portability. The translation process highlight another advantage that high-level language have over machine language, namely portability. Just like a Java. Java is a portable language. So a program for an Intel-based machine will not run on IBM-based machine, since each computer type has its own machine language. On the other hand, a program written in high-level language, say a Python program or Java program, can be run on many different kind of computer as long as their suitable compiler or interpreter have. Python program are said to be portable and Java also. Now come to our summary. A computer is a universal information processing machine which can carry out any process that can be described in sufficient details. A description of the sequence of a step for solving a particular problem is called algorithm. Now you listen the algorithm. So every logical things which need to be solved by using some steps and condition that the in organizing way of that condition is called the algorithm. Algorithm can be turned into software program that determine what the hardware physical machine can does accomplish. Just I give the example previously for making that condition in a specific way to tell the computer what need to do and when need to do and how need to do is called algorithm. The process of creating software is called programming. A basic functional view of a computer system comprises a central processing unit (CPU), a main memory, a secondary memory, and input and output devices. The CPU is the brain of the computer that performs simple arithmetic and logical operations. Information that the CPU acts on, data and programs are stored in main memory, that is called the RAM, random access memory, while more permanent information are stored in the secondary memory, that is called the disk. Programs are written using a formula notation known as programming languages. There are many different languages, but all share the property of having a precise syntax, form, and a semantic meaning. Computer hardware only understand a very low-level language known as machine language. Programs are usually written using human-oriented language, high-level language such as Java, Python, C++. A high-level language must either be compiled or interpreted in order for the computer to understand it. High-level language are more portable than machine language. Just like if we talk about the machine language, the program written for the Intel is not executable on the IBM machine. But a program written in the either Java or Python is either executable in a Intel machine or IBM machine where they have suitable compiler or interpreter. Python is an interpreted language and Java C++ is a compiled language. On way to lead about Python is use interactive cell for experimentation. Now our video is ended here. You have some idea about computer and programming language and how it is connected and what need to do. If you like the video, please like and subscribe and comment. Thank you. We will meet in next video. Thank you.